Hi and welcome to another PlayBASIC live episode. This is I think it's episode 4 in creating a library series, which we're talking about creating a very simple XML Parser. I've updated the sources, saved it as a new project, so we're ready to go to distribute the files at the very end of this episode. So far, what we do have is it will load the document, break the document down, and retrieves a kind of hierarchical structure. And it puts that into a pair of arrays that at this point we can't actually access them. We need some functions to search for these keys and retrieve them. So that's what we'll do this time, I think. That's the data, and these are the keys. So we've got the whole parent of whatever this thing is here. So PB project has includes, and it includes 0, has a visible property. Look at the console, we could work out what's going on here. So that's our PB project. This is the includes block, and in here we can read our visible property out of that if we had a function to pull it out, but we don't, of course, and we're just winging this whole thing. At the end of last video, we were sort of toying with the idea of adding a little function to grab something from it, but this time we'll do it. Okay, so this is our load function. I'll leave that there. I'll just grab the banner and place these functions above that one. Put the in function on. Of course, we can't have it just called load. Well, what are we going to call this? Call these things. Or how are we going to find? How are we going to do this from the user's perspective? So far, this is all the code that skims through the XML file and breaks it up and all that kind of stuff. That's all well and good, but how does the user's interface look? So if we know that this our XML has sprite in it, for example, well, would I have something like this? Would I have maybe a function that reads? I could just have read, I guess. We might have sprite dot color. That might retrieve our property. So that would break it down to its simplest form, I would think anyway. So I could get our color and get our name from the file, and all would be good. I can see a problem with that, can't you know? What if there are two? What if in our XML we actually have another block down here called sprite? How would we tell it which one to get? So that's probably not going to work, is it? Because internally, what will happen is they'll both be present in our structure. They'll all have keys, but for the time being, I think our solution is going to fail in that circumstance. But that's okay. So I think we'll try and do something like this. We'll just call it read. That seems fine to me. And then internally, we're going to have a few different little routines there as well. So let's create this. Let's actually make a bit of code that does this, except works with our XML Parser. Works with our. Let's just get rid of that. Read. This is a general purpose reading of a. Now I call these things keys. So we'll have to give it give it the key name. We'll call this thing the key name. So this is going to be I kind of use this piece of text here in our example, so we've got something to reference, even though we're not reading a file that's even made up of that stuff there. We probably should build a file like that later on to test this out with some kind of practical usages of XML files. Often things like editing tools, particularly tools that are trying to be generic, will spit out XML because rather than having their own format. Okay, so in our read function, what we need to do is we need to find, if the user gives us a key, we need to search for that key. Now the easiest way to do that, since we have two arrays, or sorry, an array that has all the keys in the document, we can just do a search, just do a straight linear search. We could go well, what I'll do is I'll break here. Rather than me sort of just typing stuff out, we'll go and look at the documentation. We've got these array commands in here if you didn't know, and we do have some features in here for searching. So we've got a find array cell. That might be a possible usage. Or we've got search lowest and highest. I would say probably the find array is the function we should be using. A quick glance looks like it's going to be the function. So the find array function can search either an entire array or section for either a value or a string. So if you call the function on an integer array, it'll be searching for integers. If you call it with a string array, it's expecting to look for a string. And it just returns the position from where, which is kind of the offset from where it started to search. So what we'll do is we'll go find array cell. We need our key name. Just kind of a long name, so I just cut and paste it because I am lazy. Remember that. I'm very lazy. I want out. Oops. Right, so we want to search from, actually we want to search from, yeah, that's okay. We want to search for all the way to the end of the number of used items in the array. Because I kind of know the parameters, but right. So we're searching this array. Our starting element here, our delta is actually going to be 1. And the delta is, do you want to search every cell in the array, or maybe every second, or every third, or every fourth, or something like that? You can use that there. At the very end here, we want to search for key name. Now, since we've stored all of the things in the array in uppercase, we'll grab this. I'll do it in the same line. So we'll go, key name equals upper key name. Now, if the position is bigger than -1, we found something. If it's not, there's some sort of error. So in here, as per usual, we'll just put a little to-do note. It's not really an error though, is it? If it can't find find the thing they're trying to read. It probably shouldn't error, but maybe it should actually drop something to the debug console. XML, I'll use the function name, XML read, unable to define key name of, just put the key name at the end there. So if we're running debug mode, we'll get these will pop up and kind of show us what our problem actually is. If I just do a print here, XML read, found key name, yeah, found key name, put some brackets around that, so it displays it, has some brackets around it, at index bit of a string function there, at position. So when our function here is nondescript, it has no real, because we haven't said this is a function that returns a string. And BASIC tends to like, well, traditional BASIC likes this kind of thing, where we would, and you can see now this thing's returning a string. So look at the upper command, we've got the dollar sign at the end, and the string function here, we've got a dollar sign at the end. We'll call this value. Now, value is stored, I think I'll call the data there. Same thing. Oh, using spaces there. So value string equals this thing. We're at this position. And if it's an error, we'll just say value equals 0, just to make sure it's null. Quick save. If we go back to our project here, let's try something. Now, I've actually forgotten what our fields are. I better run it again and see what's going on. Let's give us an error there. If your function name doesn't match exactly its declaration, it won't like that. So if you have a decoration on the end, like a string symbol, it expects you to have those things all the way through. Okay, so let's say we want to find the easiest one there, pbproject.version, and see if we get some data back from it. I'll just a bit of a cheat there, and I'll grab the key. This is actually what's in the array at this point. If you didn't know, this is debug view. It's probably more like a monitor, really. You can stop the program and kind of look through all the functions and look through the data and get some idea of what's going on in the program. You can't do a lot of stuff, but you can do a fair bit of stuff. And I'll just plonk that down the bottom here. Save me sort of referring back to it later on. So these are we know these keys exist in this file. We know they're there, but we want to read them out. So let's get PB project version and see if this thing actually works. It might work, it might not. We try and run it. What are we getting? I don't know why. We do get one. There it is down the bottom. I might get it to hide this material now, and we just sort of work on our little library, our usage of the library, rather than for some reason when I'm doing these captures now, it tends to push PB, the runtime window, to the back. I don't know why. Yeah, it's probably some dumb little thing. Alright, got our project. So we're reading this property as a string. If you want to read that as an integer or something else, then we would have a different version of the function. So we'd have a version of the function that returns integers. I just redefine this as integer. Make it nice and obvious. Integer value. That's the name of our variable, by the way. So here, and we can do value of whatever is returned from here. And the rest is okay. This is just going to be 0. So a bit of double up there, but it's not too bad. Yeah, so the function really just we're doing a search of the keys array. If we find our key within the array of key names, then we grab the data value from exactly the same position in the data array. We can have a floating point version of this as well. So we have our hash for float. Bit of a trick here too. Just make sure you do pick this up. So all these are floats. If it has the hash on the end, that makes it a float. But when we do val, we want to make sure we use the floating point version of. So it returns a float. If I omit that, it'll return integers all day, and you'll never get what you expect. Expecting from it. Okie dokie. I'll get rid of the other print stuff that's dropping all this garbage to the screen. Just do a bit of a search. Print. Oops. Learn how to spell print. That'd be good. It's down here. Okay. Print full parent. We won't print that. And we'll just run it again. What I often do in my own little libraries is I'll add a flag on a bit of a parallel again, aren't we? Up here, add XML library. Might just call it debug mode, and set it to true, for example. Now I can use these other statements here which are evaluated at compile time, which is what these hash statements here are. So if I wrap it in those, if this thing equals true, then okay, insert, let the print statement flow through and be compiled into the code. If I change this variable now, the compiler will just omit whatever's between this statement. It never gets compiled. And that's very useful for this kind of process when you're trying to work out, is the thing you're working on actually working, you know. I'll make that error there and push to the console. And this print here, same deal. I'll just hide it when we're in anything other than debug mode. So we set that to false, and we hit recompile. The text we've been looking at on the PV window is gone. Our debug down here has got XML read string. It found the KeyName PV project version at index position 1. That's cool. What else can we get from this file? Okay. Well, even in this, we're actually even with a simple example, we're reading its own project. The file we're reading, by the way, is actually the XML Parser project itself, which is those projects in PlayBASIC are actually just XML files, and we should actually show up our shortcomings. Here you go. So we've read our field. Our test code is down here, by the way. We've executed this, done that. The library code appears above it because all the code is really just jumbled, stuck, appended to each other when it's compiled by PV. So read XML works fine, but this will show up the shortcoming of this kind of design. Actually, it won't. Yeah, it won't. The fields inside includes have a numeric, so we have include 0. It has its own properties. Include here, so we could do a little loop. Something like this, I would say. I'll just call this our count variable include to make it a bit more obvious. I think PV projects have a maximum of 8 includes. Don't quote me on that now. I think it might be higher than that. I'll try 15. So we'll I'll grab the name, and our key is going to be this. Sorry, I'm doing a bit of 2 things at once there, aren't I? So this is our key. I'm going to add the use our loop counter there plus dot name. So that's the key we want to read, and if we read that key and nothing is there, we just assume it doesn't exist. For the time being anyway. This is the data of that key. If data, because all of these files have to have a valid name, otherwise they don't exist. If the length of data is bigger than 0, then this actually has fields. I think what we might do actually is we might put that on the end there. Go key plus name, read that. What things are stored? Name, visible, cursor color. You can probably see where I'm going with this, can't you? Okay, so we'll just print the visible, something like cursor color, and what was the other one? Cursor line Should remember that one, surely. So if I print include file and give it the, we should get those out to the screen. If we're anywhere, yeah, we do seem to have it. So the first include looks like it's correct. So include 0 here, it's name of main. It has a visible field, a cursor color field of visible is set to 1, which isn't displaying, it's probably mistyped. Cursor line 34. The second file is XML4, visible 1 again, cursor column 40 and line 27. So those ones there are reading correctly. Are we getting any errors on those? Yeah, there we go. Unable to find key name of project includes visible. Oh, I spelled it wrong. Ah, I did too. Visible. Let's try it again. Now, I realize this is pretty simple, but we are actually retrieving data from this sort of complicated structure. And it's fairly easy though, isn't it? It's not, once you've got the program up and running, yeah. See here where we found a key that doesn't exist. Oh, sorry, we've asked for a key that doesn't exist, and so that actually works correctly. We're pulling all the data out of there that we've asked for. Gee, I hope I'm making a bit of sense there. I'll just print a little thing. This is the include files, which is true. What other information do we have hidden away in here? Oh, I'll grab the screen properties of the project. There's a typo in height there that tripped me up in another project I was writing too. Screen width. Oh, should be a string. These are the default sizes the screen can be that you can set up in the project, by the way. Under project, under settings, you can set a screen size, and so by default it's set to 800 by 600 with 16-bit. You would only get 16-bit if you were actually trying to run this in full screen mode, if your video card even still supports 16-bit. If you pick a mode, the depth that's not supported, it will actually try and look for an alternative for you. So it's kind of become redundant, to be honest. The size isn't redundant, but the depth kind of is. Oops. Doesn't matter if I put those in uppercase anyway. Now I think height is spelt wrong, wasn't it? There it is. Yeah, it's an old typo that happens to be in these documents. Let's run again. Oh, stuffed it up. What have you done there? Oh, missed the closing quote. Screen depth is not working, is it? So maybe it's not called depth. Look at our console output. Saying it found screen depth at position 18. So, yeah. I wonder if that's the case. Let's look at the... Shouldn't have stopped that, should I? Look at the console. Ah, there it is. So depth is 0 and mode is 1. The mode is actually referring to whether it's windowed or full screen. I don't want to change that because we're actually capturing this as we go through. That actually is working. That's the depth that's set up in the project. I have a feeling it uses. So it's a long time since I looked at this stuff. I have a feeling that we're actually representing the modes. Sorry, the depths is like as an array. So what I mean is that internally there's probably a table where, you know, an array table where depth 1 is just looking up 16. If that makes any sense. Probably not. But we do have a little working phrase where we can read the file in, get some very basic information out about it. It's not a very fast and elegant solution, but it does actually do what we're asking it to. We'll just make that a little bit more elegant. Visible. What's the cursor column and cursor line? Wish it would stop doing that on this computer. Okay, so our include file, and we are, yeah, file is this. We've got visible 1. Very cool, very cool. Is there anything else in there? Oh, we've got creation dates. We can grab those out. Okay, dates created and edited. What I would say about what we've got at the moment is that it's okay for this kind of, if you've got a small number of properties and you don't have massive files, then you could just do it like this. Why not? Let's run it again, see what we get. And we have our creation dates. So pretty much any time I put in one of those fields, we'll get a response. And if we get nothing back, it doesn't exist. What we could have is a secondary function that checks whether a key exists. So we could go that's our read functions block. We could just do it up here. End function, yeah. So we try it this way here. We'll pass it our key name and just return this process here. we'll have result. Then here we'll just do result equals result greater than -1. That's a little Boolean operation there. So what we're doing here is we're doing the comparison first, which will return a 1 or a 0, and then we're writing this back to result. So a function now returns a true or false. And this would help us for things where we're not sure if something is in our little database or not. We could use this up here. Once we've constructed a key like that, we could go, let's check if that key exists. And once we know it exists, then we read our data and we read the name. So we kind of don't need this here. So we're checking to see if the key exists in our little database. If it does, it grabs the name, is it visible, the cursor, etc. from it, and prints it to the screen. If it doesn't, it should just skip over them. So we shouldn't get information dropped to the debug window for other chunks, other keys that are not existing. That's better. So every time we're doing a request, we're requesting something that actually exists. So we're not getting any errors from our library saying that we're looking for something that doesn't exist. Because we've got our little helper function there that does that thing for us. It's just like having, if you've played with sprites in PB, there's commands for, get sprite status. You might have a statement like this, and this sprite index or something like that. So you would check if the sprite exists, and if it does, then go do a bunch of stuff with it. Set its rotation, position, whatever you want to do. Same principle here. To help the user use our library easily and be less error prone, it's just nice to have those little sort of helpers in there. We could just have, get key exists. It's probably a little bit more consistent. Just add a little banner to that. Yep, I know we're rushing through. We're always rushing in these things. I'm sorry about that. So KeyName exists in our current document. Now, that's one of our limitations at the moment. Now, the library will work okay if you've got a small XML file, and it doesn't really work at all if we have multiple XML files that we need to load and actually do something with, because at the moment we can only have one load into memory at one time. We can solve that problem, and it's not as hard as you think. But I might actually leave that for another time. But for now, this is our a little XML phrasing project is actually up and running, and it's as useful as can be so far. So check it out, and anyway, thanks for watching, and I'll catch you some other time. Bye.